Atoms are constantly arriving at the surfaces and adding themselves onto those surfaces in an orderly way. And they're doing this at an amazing rate of speed. The crystals you're looking at are growing fairly fast. Suppose a crystal grew at the rate of only a couple of millimeters a day, which is fairly slow. You can calculate that about 1,000 layers of molecules would have to be laid down per second on the surface of that crystal. And all the molecules have to be laid down in the right sort of order. I want to borrow a trick from Sir Lawrence Bragg to give you just a rough idea of some of the things that we think must go on as a crystal grows. Sir Lawrence blows soap bubbles. He blows them in a pan of soapy water, tiny bubbles which rise to the surface and collect in rafts. The bubbles behave a little like atoms because when they're floating on the water, they attract one another a little. And when they touch, they stick to one another quite strongly, as atoms do. But, again, like the atoms, they have a squashy sort of size so that they take up space. Watch how the bubbles collect together into an orderly arrangement. It's the same as the arrangement of pennies I showed you, the so-called close-packed arrangement. Notice that the rafts are made of large parts. All of the parts have the same sort of order, but the orderliness of the parts is turned in different directions so that there are grain boundaries between the parts. This is like a solid made of lots of crystals which started growing in different places and finally joined. It's like the sailal after it is all solidified, or that brass door handle. When you think of how fast the atoms have to get into order, much faster than this, the more astounding their achievement seems to be. But this will give you some little idea of what a hustle and bustle must really have to go on an atomic scale.